Viewers, good day. It's been quite a long time ago we connected, and as promised to my people, we are resuming, and I have amazing content as usual. And I'm glad that in the past few months, I've been getting feedback on several of our posts that we made before now, and people are really benefiting from all of those posts. And today, I'll be taking us through something simple so that we build up from there. Like I said, be expecting amazing content. I'll be giving engineering solution, taking you step after step in having engineering and structural solutions. Yes, so today I want to show you how to detail a two-way simply supported slab. I'll show you how to go about the detailing of a two-way simply supported slab. Of course, we know that a two-way simply supported slab, as shown to you, here we have the longer span, which is the ly, to be 5 meters, and the lx, which is the shorter span, to be 4 meters. So the aspect ratio is definitely less than 2. So we know that such is a two-way slab. And considering this as a two-way simply supported slab, it means that there is no provision for torsion at the end supports, right? So it means that the moments are considered to be acting at the spans. Yes. So I'll show you something from the BS code, from the BS 8110. Yes, we have uh, something as this. Now, in the case of this, you see that there is provision for moments for torsion at the edges, at the supports. Meanwhile, this that we are speaking about, that we want to consider today, has no provision for torsion at the support. So that is why we call it the two-way simply supported slab. So in the normal analysis and design of such slab, this is what we consider. We make use of this bending moment coefficient following the aspect ratio ly over lx. You obtain a value, and whatever value it is, um, you obtain over for this ly over lx. You find the corresponding value for your alpha xs and alpha xy. Then you make use of our formula for moment. Then you obtain your moment, then run your design. Then having obtained, I'll show you how to do that in another separate video, how to um, design a two-way simply supported slab. I'll show you in another video, but now I just want to show you how to detail. So having obtained your reinforcement from your design, then knowing full well that your simply supported two-way slab is not going to provide for torsion at the edges. That is to say that we are only catering for the moments at the spans. Yes, so we are just going to run a quick detail, and I'll show you how. Okay, so we go just like this. So we know that the the for a slab, we span the main reinforcement span along the shorter span, the longer span rather, where it spans along the longer span. So we have this, we have the reinforcement coming this way. So this automatically becomes our main reinforcement. But mind you, your reinforcement cannot be like this. Yes, there ought to be a provision for cover and anchorage also. So we assume a 150 thick slab in this case. So, and I take my cover as 20. I assume my cover as 20. So from here I observe my cover 20 you see that. So then if you are going to find the effective depth for your slab, 150 mm thick slab, you remove your top cover and your bottom cover. That's 40 from the 150 mm thick slab, so that's going to give you 110 mm. Yes, so I have that. Then for this, I'll show you about the anchorage. I'll show you this. Yes, so the same thing apply to this. So let's run for this also. I'll show you the anchorage now, and how we go about that. I'll show you. Though for this end, like I said, there is no provision for moment at this end. So there is no provision for moment at this end, but I choose to put it there, and for certain reasons I prefer to do that. Okay, so I'll show you something from the BS code 8110, and it's about how to provide for anchorage and some other stuff when it comes to detailing. I'll show you. It's on page 90. Yes, this is what we're going to. So this is for slabs, and considering what we are doing there, we are having a simply supported slab. Yeah, so this, if this is a simply supported slab and we have this as the face of our support, you get it. So we have provision for it. For continuous member, you have all the factors for providing for your reinforcement when it comes to detailing. So if it's a cantilever, you have all that is required to do that. Okay, so for this one, following what is given in the code, you see 0.1 of the length, that is for this, which is for reinforcement for maximum moment at the mid. This is for the mid span. This is for the mid span. Okay, so this is for equivalent anchor. You see, diameter multiplied by 12, or equivalent anchorage. Okay, so, and we have 0.1 of the length. Okay, so let me go this way. So if this is 4 meters, according to what I just showed you in that code of practice, so we have 0.1 multiplied by the 4 meters, then we have 400. So from here I can just extend it and say I have 400. Okay, so that's cool. So from here also we do the same thing. We have 400. Cool. Okay, so I have my main reinforcement like this. Okay, so but it's going to span right from here down to this place. So then I'm going to do that real quick. So to that, do that real quick. Now, how to calculate the number of reinforcements that will span right from here down to this place? How do we calculate that? I'll show you that also shortly. So if this reinforcement is supposed to span along this longer span, so it will mean that I will have this, which is the total span, but mind you, the center to center spacing, or center to center dimension rather. So that is to say that I'm going to take my dimension back to this place and this back to this place, which is 112.5 from the center, from the grid line. So I'm going to subtract 225. So 225 means that I'm subtracting 112.5 on this side and 112.5 on this side. So I am working with in to in at this point now. So from the face of this beam and from the face of this beam, internal face of this beam and the internal face of this beam, I would have a little, because the reinforcement cannot lie directly on the face or the inner face of the beam, so we have allowance of 50 mm on both sides. That's 100. So I have that already. So that is what I'm working with. This is what I'm working with now. This is what I'm working with. So I'll divide this by the required spacing that I obtained from my design. So if I'd obtained a white of reinforcement at 150 center to center bottom for my reinforcement, so I'll just divide this by 150 so I have 31. So I'll just find a way to fix this very neatly, and we'll have something like this. Okay, I have something like so we have 31, and this also 31. So let me just go again and show you how I got that, so that we'll be on the same page. This is going to be a bottom bar, not a top reinforcement. Okay, so I'll show you how I got that. This is 5 meters center to center. So because I want to find how many of this reinforcement would span from this inner face down to this inner face. So, and I'm supposed to take that dimension as I just explained. So I'm going to see how that I'm going to get the distance between this inner face and this inner face. So I subtracted the center to center from this center to this inner face, which is 112.5. I subtracted from this end, and also I subtracted from this end. As you can see in this place, it gives me 225. Okay, so I'm now at this inner face, but because this reinforcement cannot lie directly on this inner face, so we give an allowance usually of 50 from this inner face. So I remove 50 from here and another 50 from here, then that is why I have this. So having obtained this, I have 4675 as the dimension to work with. So my design, I assume that my design reinforcement is Y12 at 150 center to center bottom reinforcement. So I just divide by 150, then I obtain 31. So that is how I got about that. Thank you. Okay, so for the other reinforcement, which is the bottom reinforcement now, it spans from here down to this place. Okay, so and the same thing applies to the length, to the anchoring length. So we have that already. Okay, so then I have the same way I did the other one, multiplying the span by the factor obtained in the code, which is 0.1. So I have 500. So 500. Then the same thing applies to this. Like I said, I promised to do a separate video showing you how to design two-way simply supported slab, and I'll do that in a separate video. Okay, so we have 500. Okay, so this is cool. I have this now. Now to detail to point out the reinforcement details, I'll fix in this also. I'm fixing this. So I have these and this. Okay, that's cool. And this is just to make my my detail a little bit neat or better than flying lines all around. So as you are trying to pass your design with results into the detail, also ensure that your work is well represented and it looks appealing too. Your details are not really clumsy. Yes, so that is one of the things you need to learn as an engineer, that your details are well represented and well presented. Yes, it speaks more about what you do and how well you do it. Okay, so with this also, this reinforcement is going to span right from here to this place. So let me rotate this so that it wouldn't confuse. Yeah, thank you. So it's going to span from here to this place. So I'm just going to do the same thing I did the other time, and I want you to pay attention in case you didn't get it that time. Yes, so I'll just do it. I'll just do it now. So this is supposed to be bottom distribution. Yes. Okay, so I just did this 4 meters and I subtract 225. Now I'm on the inner face of the beams. Okay, so then I'll subtract the allowances, which is 50 on both sides, 50 mm on both sides. So width left which leaves us with 3675. Then you divide by, assuming we have 250 y12 and 250 spacing for the distribution reinforcement. So I have 14.7. So this I can say I'll provide 15 y12 O2 at 250 7 bottom distribution. Very simple. So I have it this now, and my detail is well available now. Okay, so what next do I need to show you on this? Okay, so this is how to detail the plan. So if I'm to provide an elevation or a section rather for this, a section for this, so it's very simple, and I'll show you also. And let's just go like this, and I'll be a little fast. So we assume a 450 deep beam supporting the slab. Okay, so and the 450 by 225 beam supporting the slab. I'll just do it a little bit fast. I believe I have videos showing how to use your AutoCAD software and how to manipulate all things that you need as to the tools. So you shouldn't have problem with how to draw all this. Yes, and if you have any, you can reach out to me and I'll put you through. Okay, so let me just frame out the slab and we get to work. So a two-way simply supported slab does not provide for torsion at the edges. Yes, so but a continuous slab do provide for torsion at the edge. So you need to first identify what you are designing or what you are detailing so that you can safely represent your design. You can even safely do the design and represent your data appropriately. Okay, so having done this, let me match appropriately. Then when I have this already, okay, then having this. Okay, just to make it clear. Okay, so good. So this is the distribution bar on the plan. So of course here is going to show as the distribution bar. Now meanwhile, because its distribution is supposed to show above the main reinforcement, so you should note it very well. So you see the effect now, you see what I'm trying to show you. Instead of it being this way, instead of it being this way, somewhat like this, instead of it being that, you have your reinforcement rolling just over that particular, yeah, instead of being like this, so it's not going to be like this, it's just going to be a little bit different, such that this is going to be above this reinforcement, because as I explained, this is the bottom reinforcement, this one is the bottom distribution, while this is the bottom reinforcement, and whatever you do on that plan must be well represented on the section. Yes, so you see what it is. So let me just make a copy once, then yeah, then cool, cool, cool. Okay, so let me make two more, then we are cool. Okay, that's fine. Okay, so let me just put a little detail, then remove. I really hope that you all are getting what I'm doing. In case you find it a little difficult, you just call my attention, drop comments, and I'll be glad to attend to all. I'm sure by now all comments have been attended to on every post, and my even my contacts have been dropped so that I can reach out to people if needs be. Yes, because the goal is to make everyone understand what you do. Okay, so I have that done. So simple, and I know that you all got that right. So I'll just put this and we're done. We're cool. We're cool with this. Yeah. So don't mind all of this. As soon as you get these little things, you'll be able to do something like this. Okay, so this is Y12 O2 according to our detail. Yeah, this is O1, right? So that is just how to go about a two-way simply supported slab. This is section 1 and this is the plan. So it's very simple and straightforward. I really hope that you understood this simple way of detailing your two-way simply supported slab. In the next video, I'll be bringing to you how to detail a continuous slab, both one-way and two-way continuous slab, and also in subsequent videos I'll be showing you how to design manually, and also with software how to design slabs of different kind. And do like and subscribe